Okay, today we're going to look at tangents to a circle, so a special kind of line that only touches a circle in one place. So looking at our diagram here, we've got three lines. We have a green one, a blue one, and a red one. The green one doesn't touch the circle at any point, so that's just a line. Doesn't really impact what we're doing at all. The blue one goes through the circle, so it creates a chord from this point here through to this point here, creates a chord inside the circle. The red line doesn't pass through the circle, it only touches it in one point. That gives it a special name. It is called a tangent, and the line is said to be tangential to the circle. Okay. Tangents have some special properties. The most important one is that if you draw a line from the radius, it's better if it's from the radius, from the centre to the edge as a radius, the radius meets the tangent at 90 degrees. So this angle here is 90 degrees, and that makes it 90 degrees on both sides. And that can be really, really useful and helpful for us when we are calculating angles in circles. A typical question will look something like this, where we have a tangent. It's not always going to be along the bottom. It could be at any point on the circle in any orientation to the circle. I've just drawn one along the bottom so that it looks nice and neat. We have a radius from the centre to the edge and the point where the tangent is touching, which means that this angle here is 90 degrees. Most of the time the question is not going to give you that. It's testing to see whether you can remember that. Then it will ask you to work out some other angles. In this case, we're going to work out angle X here, and we've been told that this angle at the base is 40 degrees. So we can use our knowledge of the angles in a triangle to know that there's 180 degrees total. We've used 90 here with the right angle and 40 here, which is a total of 130 degrees. So angle X must be 180 minus 130, which is 50 degrees. So X equals 50 degrees. Sometimes it'll look slightly different. You could get one that looks a bit like this, where we have a long line that's gone right through the circle. It's touched both sides and it's gone through the centre, so that's created a diameter going through here. And we also have another line which is tangential. It's only touching the circle at one point here, and if it carried on, it would come away from the circle. It wouldn't touch it again, which means this bit at the bottom here is 90 degrees, and we're asked for both X and Y. So we have to use a couple of different skills here. We have to use our knowledge of supplementary angles to know that the angle in a straight line is 180 degrees. So if we've used 110 out here, then X must equal 70. 180 minus 110 is 70 degrees. So X must be 70. We've used 90 at the right angle, and 70 is 160 degrees. 180 minus 160 leaves us 20 degrees. So Y is 20 degrees. And just a quick check, 20 and 70 is 90, 90 and 90 is 180. So that works and that is correct. Sometimes the person that set the question will have gone a bit wild and they'll have lines all over the page. Don't worry when you see something like this. This is one where we're going to just start at one point and work our way through it. The first things we're going to be looking for are tangents and chords, because they'll help us set our triangles. So at the base here, we have a tangent, which means that this is 90 degrees on both sides there. And if we look over here, we have another tangent that comes down this way. And that tells us that this angle here is 90 degrees. Okay, so if we're going to work out all the angles in this diagram here, then we would maybe start here, and we have supplementary angle to this 90 degrees, so that's going to be 90. Supplementary to this one over here, that one's going to be 90. This whole bit around here is going to be 90 as well. I'm not going to write that in just now because it will block out some of my pictures. Some of the other things that I'm going to have to write in here. Okay, so if I go back to my first triangle at the bottom, it's the only angle that we were given was 30 degrees. Because of the tangent, we know that this is 90. 90 plus 30 is 120. There's 180 degrees in a triangle. So 180 subtract 120 leaves us 60 degrees. Now we can use some of the skills that we've had, maybe we've refreshed recently. So a vertically opposite angle here makes this one here 60 degrees. Our supplementary angle, our supplement to the 60 degrees, is going to be 120 degrees. Vertically opposite on this side, again, 120 degrees. Okay, we're getting there now. Let's have a think about this one at the bottom here. How are we going to get to this? It's part of a kite, but it's also part of a bigger right angle triangle. It goes all the way along the base. This is its right angle, and it comes down to here. So, if we have a 30 degrees and 90 degrees, that's going to leave us 60 degrees down here as well. Okay, now we've got some awkward ones up here. How are we going to do these? We know that this is a radius, and we know this is a radius. So that's a good place to start. So we have our isosceles triangle here, which means that the base, these two are going to be the same. So we have 180, we've used 60, that leaves us 120 degrees that we need to split between these two angles equally. 120 divided by 2 is 60. So we've actually ended up with an equilateral triangle. That only leaves us this one angle here to fill now. So this whole angle was between this line, the tangent, and this line, the diameter, was 90 degrees. We've used 60 here, so this part here must be 30 degrees. That's the kind of thing you're going to have to do when you're working through questions like this. It's a case of find out the angles that you know, and start at that point, and then just keep filling in triangles and looking for things like vertically opposite angles. That'll really help you. Okay.